Hello everyone, I am Hossein Azizollahi and welcome to Pragmatic Programming channel. This is the first episode of C# programming tutorial. In this series, I'm going to teach you from very basics of programming to the intermediate level of how to program with C#. Though the start is very different. The start is not about just C# programming, but it's about the very fundamental of programming. And then we will continue to talk about how computers work. Now let's see what do we do have for today. Today, first I will talk about what is programming components, and then I will explain about basics of logical circuits, which is important because it will help to understand how CPUs work. As you guessed it, that's the next topic. And when you know how CPUs work, it will help you understand what is happening when you write some lines of code, right? And after that, I will talk about programming languages and their types, their differences. I'm not going to cover all the programming languages, but I will talk a little about the most famous programming languages so that you can know what are the differences. And finally, it's time to learn about pseudo-codes and flowcharts. And at the end of this video, I will provide some practices for you to do it and make yourself ready until the next episode, though their answers will be ready in the following days. So check that out. So what is programming? Well, the programming is a way to write programs that can run on computers. And when I say computer, it can be a PC, a cell phone, embedded devices. It literally can be any type of computer. So when I say a computer, I don't mean a personal computer. It can be a laptop, a tablet, anything. Literally any type of computers. Even it can be your refrigerator, right? Your refrigerator does have a computer. So when you learn how to program, you can write some program for even your refrigerator. So now I'm going to talk about real world usages. The programming, if you learn it, you can write program that can be run on robots, run on your car, your smart house, websites, the PC applications, all sorts of applications that you see on your computer. It's used for creating animations, movies, games, etc. Okay, now let's talk about career path. The options you have once you learn how to program are either becoming a backend developer, front-end developer, mobile developer, or IoT developer. Backend developer writes program that will run on the servers. So if you choose to become a front-end developer, let's see what is front-end when we say the front-end. In here, when we say for front-end, we are talking literally about the uh, web applications, right? What you see on a website, for example, when you go to Amazon, what you see, the visual elements on the website are the work of front-end developers. They use the HTML, JavaScript, CSS, and things like these things. Now, if you choose to become a mobile developer, these people, as its name explains, will develop applications for Android, iOS, etc. And if you choose to become an IoT developer, what is the IoT? IoT stands for Internet of Things, right? So when you choose to become an IoT developer, you are likely to develop the applications for for example, ATM machines, a refrigerator, for a car, in general, for the embedded devices. So now let's talk about important components of a computer. First is CPU. CPU stands for Central Processing Unit. It is the brain of your computer. All the codes you write will be executed in this unit, right? Next one is RAM. It's a temporary memory. CPU use the RAM to fetch the data, either to perform some operations on it or just fetching the actual code you wrote. And the next one is graphic card. As its name explains, it will render all the graphics of your computer that you need to be rendered. Now let's talk about the motherboard. The motherboard is the place where all of the other computer components will be plugged into it. For example, the CPU you have, or RAM, or graphic card, or etc. Okay, now let's talk about basics of computer logics. The first logic is AND logic. This is the symbol of AND logic. As you see, it has two inputs, X and Y, and there's one result. And to explain it, there I made a table. If the input of X is 1 and the Y is 1, so the result will be 1. So the X and the Y will be 1. That makes sense. If the X is 1 but Y is not 1, X and Y are not 1, so they are 0, right? That makes sense. And the same goes for the rest. So the only condition that both X and Y are allowed to pass, or the X and Y result will be 1, is when both of them are 1. So X and Y might have some, in the real world, they might have some voltages. For example, this one, when we say 1, it might have around 5 voltage. And when we say 0, it might have around 1 voltage. So the 1 voltage will be assumed as logical 0, and 5 voltage will be assumed as logical 1. Now, the next logic is OR. The symbol is simple, as you can see it, 2 input and 1 result. Again, the table explains everything. As you can see, if just one of them is 1, that's all enough. As you can see, X is 1, Y is 1, result is 1. X is 1, Y is 0. X or Y is 1 because one of them is 1, so it makes sense to have it 1. The result will be 5 voltage, right? And the same goes for the rest. The next logic is NOT. The symbol is this. The table is very simple too. If X, which is our input, is 1, our result will be 0, right? The next logic is NAND. The NAND has also 2 input and 1 output. Inputs are A and B, and output is Y. As you can see, the Y will be 1 only and only if A and B is 0, right? Let's go to the next logic, which is XOR. Very important logic. The symbol is this, and there's a table. A is 1, B is 1, Y will be 0. If A is 1 and B is 0, Y will be 1. And if the A is 0 and B is 1, Y will be 1. And if the A is 0 and B is 0, Y will be 0 too. As you can see, the Y will be only 1 once only one of A or B is 1. So let's go to the next. I made a real-world example of adding 2 numbers. Well, it's a very simple example. As you can see it. It will logically AND 3 inputs. As you can see, these are all base 2. And it's a very simple example. There can be way more complicated circuits, which we're not going to talk about them right now. So we'll leave it off here. Going to the basics of a CPU. Well, it is made by combination of billions of circuits, as you saw. And the question, why numbers are base 2? Because it's simple and energy efficient. For example, that logical 0 is almost 1 voltage, and the logical 1 has around 5 voltage. You see, you might say, okay, in this example, what if the voltage that it's receiving is between 1 to 4.5? It's neither 1 or 0, right? Well, that will be considered as a noise. Okay, another thing is that I'm going to mention is the CPUs have their own memory and they are called registry. And you might ask why another memory instead of RAM? RAM was a memory and now you're using another memory. Well, first, the registry capacity is way lower than a RAM. And it's way faster than a RAM. This is a schema of a CPU. As you can see, the CPU fetches data from bus into its registry. This CU that you see here stands for control unit. This ALU that stands here is called arithmetic logical unit. And now let's continue to general flow of computers running apps. There's a hardware on your motherboard called BIOS, which have a software that is made by your motherboard manufacturer. What it does, once you start your computer, it will be loaded, and then it will gives you some management over the settings of your motherboard. So what happens once you start your computer, BIOS loads up, and then the BIOS will load the bootloader that you told it already that where is your bootloader. It will load the bootloader to the RAM and then pass the execution pointer to the bootloader, right? Then the bootloader loads the operating system kernel into the RAM and then passes the execution pointer to the kernel. Then your operating system starts loading the drivers, the services, and the apps required to be used on your computer, and then you will go to sign in and just use your PC, right? We're not going to talk about the drivers right now, but we will get to it later. Now, what are programming languages? The programming languages are the tools that let us build applications that can be run on any computers. And there are three types of programming languages. First are those that will be compiled and then run on your PC. So you write your code, then you will give it to a compiler. That compiler will compile it to the codes, to the 0 and 1s that your CPU can understand what are they. And then it will be run on your CPU. So another type are those that you will give your source code to a compiler. Then the compiler compiles it to an intermediate language, and then that intermediate language will be loaded into another application, which that application will run your code for you. The examples are Java and C Sharp, which when you write some code in Java, you give it to a compiler. That compiler compiles it to an intermediate language. Then for running that compiled code, you cannot simply just double click on it to let the CPU run it, but you should give it to Java Virtual Machine to run it for you. Now let's talk about what is pseudocode. Well, pseudocode are not actually the code. You write something that doesn't really bounce to any specific rule. Let me explain you this by a very simple example. Assume that we will write a program that will receive two numbers to just compare to see which is greater than the other one, right? We will start with a begin, then we will introduce our two variables, then we will display enter the first number. So then we will write input x, which if user writes any number, we will receive it and put it into the x variable. Now the x variable does have a value in it, and it is the value that the user just entered. Now we will write display enter the second number, and we will receive another number by writing input y, which if the user writes any number, we will have it stored in our y variable. So now our y variable will have a value that is received by the user. Now our y variable will have a value. Well, then we should check if x is greater than 1, then display x is larger than y. Else display y is larger than x and n. Well, because it is a pseudocode, it doesn't require you to follow any rule, really. You just can write whatever you like it to write. Well, what is the flowchart? Flowchart is actually like a pseudocode, but instead of writing things, we just draw shapes, right? It has some symbols that you should know. There's a terminator, there's a process, document, decision, data. So now let's go for an example. As you can see, I draw the last example as a flowchart, not a pseudocode. That terminator, you see, we have a start and an end. This is our terminator. And in here, you can see that there's a display entered the first number, which is inside a rectangle. As you can remember, the rectangle was for processing. So in the process, we write display the first number. Then in here we retrieve the x. Then we display the second number. Retrieve y. If x is greater than y, yes, display x is larger than y. And if this one was no, then display y is greater than x. And as you can see, it is very, very simple. And remember that this is the very first step to write code. Now the exercises. Question number 1. Draw a flowchart to find the sum of 5 numbers. Question number 2. Draw a flowchart to log into Facebook account.